today at straight line graphs. Now, what are straight line graphs? Well, they are when you plot some coordinates and you get a straight line that looks maybe a little bit like this, but it can also look like this, or like this, or like this. There are many different ways straight line graphs can look. But how do we get the coordinates to be like that and to form straight lines? Well, that's what we're going to look at in a moment. Now, each one of these lines has to have some way of defining itself, because how could we tell the difference between the yellow line, the blue line, the red line, or the green line? Well, every line has an equation, and that's what defines it. And an equation, remember, has to contain an equals sign. So it's this equation that defines the line, and it also enables us to get the coordinates that form that line. So let's have a look at some examples. So example 1 says plot the graph of y equals 2x. So here we have an equation because there's an equal sign there, and we can get some x and y coordinates from this equation. So here I've just put down some values of x. So I've put x is minus 2, x is minus 1, x is 0, x is 1, and x is 3. And I'm going to use those to get myself some y coordinates. Now, how do I do this? I need to substitute in the value of x into my equation. So here, if x is minus 2, I'm going to do 2 multiplied by minus 2 to get my y value. So 2 multiplied by minus 2 is minus 4, and that's my y value. I'm going to do 2 multiplied by minus 1 to get my y value for when x is minus 1, and that gives me minus 2. If I put 0 into here, I'm going to do 2 multiplied by 0, which is just 0. If I put the x is 1 into here, it's 2 multiplied by 1, which is just 2. And then if I put 3 into here, I get 2 multiplied by 3, which gives me 6. So that is a 6. Now remember, this is 2 multiplied by the letter x. It's being multiplied because they've been pushed together, not because that's a time sign. That is not a time sign, that is a letter x, and it represents your x coordinates. I know it's 2 times x because those things have been pushed together. So now I have some coordinates. I have x is minus 2, y is minus 4. There's my little coordinate there. I have x is minus 1, y is minus 2. I have x is 0, y is 0. X is 1, y is 2. X is 3, y is 6. And now I can plot some coordinates. So let's do that. Minus 2 minus 4 goes here. Minus 1 minus 2 goes here. 0, 0. 1, 2 goes here, and 3, 6 goes here. And that forms to join a nice straight line. So I will go through that with a straight line. And there we go. That is the line y equals 2x. Let's do the same for y equals minus 3x. Now this means minus 3 multiplied by my x value. Now if x is minus 2, I've got to do minus 3 multiplied by minus 2, which is positive 6. Minus 1 multiplied by minus 3 is positive 3. Minus 3 multiplied by 0 is just 0. Anything multiplied by 0 is 0. Minus 3 multiplied by 1 is minus 3. And 2 multiplied by minus 3 is minus 6. So let's plot those coordinates. Minus 2, 6 is there. Minus 1, 3. 0, 0. 1 minus 3, and 2 minus 6. Okay, let's join up those lines in a nice straight line. And that is the line y equals minus 3x. And you might notice that the lines going like this are what we call positive. They have a what is called positive gradient, and I know that because this is a positive 2 and it's going from bottom left up to top right, whereas this one is going from top left down to bottom right, and that has a negative gradient, and I know that from this symbol here. Okay, 2 more examples. Plot the graph of y equals 4x minus 3. So I'm going to do 4 multiplied by minus 1, which is going to give me minus 4. And then I've got to minus another 3. So what's minus 4 minus another 3? It's minus 7. 4 multiplied by 0 is just nothing. Minus 3 is minus 3. 4 multiplied by 1 is 4. Take away 3 is 1. 4 multiplied by 3 is 12. Take away 3 is 9. Now I have some coordinates. Minus 1, minus 7.